Okay, so in example number 2, we have a 4-term polynomial. I have the terms 3a cubed, negative 9a squared, 5a, and negative 15. Before factoring by grouping, I just want to check, is this factorable by GCF? Is there a greatest common factor that exists in all 4 of my terms? However, the last does not. So A is not part of the GCF. If I look at the numbers 3, 9, 5, and 15, the common factor between all 4 of those numbers is the number 1. Even though 3, 9, and 15 are divisible by 5 is not divisible by 3, so 3 is not the greatest common factor. So we checked to see if we can solve it by, or factor it by GCF. It's not factorable by GCF, so the next method we're going to try is factoring by grouping. So it looks like if I group the first 2 terms together, and then if I group the second 2 terms together, let's see if we find any common factors. So in 3a cubed minus 9a squared, it looks like both of those terms have an a in common. Not only do they have an a in common, they have a times a in common, or a squared. So they both have a factor of a squared. I'm looking at the coefficients 3 and negative 9. Those 2 numbers are both divisible by the number 3. That's the largest factor. So I see that my GCF for the first 2 terms is 3a squared. So I'm going to factor out a 3a squared from the first 2 terms, and 3a cubed divided by 3a squared is equal to just a. Negative 9a squared divided by 3a squared equals negative 3. So I factored a 3a squared out of the first 2 terms, and now what I'm going to do is look at the last 2 terms in this polynomial. So in 5a minus 15, what is its greatest common factor? Well, the first term has a, the second term does not, so I cannot factor out an a. Looking at the numbers 5 and negative 15, it looks like the greatest factor for 5 and negative 15 is the number 5. So what I can do is factor out a 5, or divide both terms by 5. So that's positive 5 that I'm factoring out. 5a divided by 5 equals 1a. Negative 15 divided by 5 equals negative 3. So now what I see is, by factoring by grouping, the first 2 terms had an a minus 3 as a factor. The second 2 terms had an a minus 3 as a factor. So what I can do is factor out an a minus 3 from both of those terms. So factoring out an a minus 3 and an a minus 3, because they both have an a minus 3 in common. When I factor out an a minus 3 from the first term, I have 3a squared times a minus 3 divided by a minus 3, which is equivalent to 3a squared. 5 times a minus 3 divided by a minus 3 equals positive 5. So this is my factored form of the polynomial. To quickly check that I did this correctly, again, I'm using the distributive property. A times 3a squared, a times 5, negative 3 times 3a squared, and negative 3 times 5. I get 3a cubed plus 5a minus 9a squared minus 15. Checking to see that that polynomial does match the original polynomial I started with. It looks like even though they are in a different order, they are the exact same terms. So yes, I did factor this correctly, and this is the correct factored form of that polynomial. What I would like you to do is spend the next maybe 5 to 10 minutes working on examples 3 through 6. Please pause the video here for the next about 5 to 10 minutes or whenever you're ready to look at the answers.